Okay, guys, welcome to the class. Today we are going to deal matrices. It's one of the most important topic for means. Definitely, you people have to learn this perfectly, guys, because there is a chance to get full and full marks in matrices, right? So last 10 years, since last 10 years, nobody is going to miss the marks in related to this matrices related questions. Everybody attempted, my student, everybody attempted these questions and they got the marks, right? So here, matrices, usually we are going to divide in three parts, Nana. First, basics, we are going to discuss, then afterward, determinants, and the last one is linear equations. Okay, these are the three parts are there. Let's start this one. Okay, matrices, basics. See here, what I'm going to do in this session. I would like to discuss complete theory. Then afterwards, two parts of theory. At least two parts of the theory I'll discuss. Third part is linear equation is there. That also, okay, we'll deal later. But first two parts of the theory I would like to finish. And concern problems, around 30 to 40 problems I'll discuss. Some PYQs and good questions. And the next one is after this class, immediately I would like to upload one assignment of 30 questions and one question paper of 30 questions. One question paper, one assignment. These two okay, upload. You please do this much is more than enough for final preparation. Okay, I'll select some PYQs in question paper, 15 questions from PYQs and 15 good questions from other books. Right. So this is I'm going to do. So now let us start for this one. See, Nana, here in the first part, this is what part one I'm doing here. Three part I said, part one. Right. The part one is a rectangular arrangement. See here, the rectangular arrangement. One. Yeah, you see that part one I'm going to do. Everyone should have a clarity in theory, Nana. That is the most important one. The first one is, what is that? See, a rectangular arrangement of numbers in rows and columns, you can call it as matrix. Right. So simply I want to write here like this, 1, 2, 3. This is one example. Right. Another example is 2, 4, 6, 7. Yeah, this is another example. This is first one. And the second one, you see, order. What is that? Order of a matrix. Order of matrix. Right. What is the order of matrix? A matrix having m rows. Okay, n columns. M rows and n columns. You remember here, m rows and n columns. Okay, is called is order. And we are denoting with what? M by n. Like this, m into n. And we are going to read m by n. Like this, we are going to say now. So this is what order. Suppose here example I'm giving you. See this 1, 2, 3. Suppose if I write here, how many rows are there? Means one row horizontal, right? One row. How many columns are there? Means 3 columns. Yeah, we are going to write like this. Suppose if I write 1, 2, 3, 4, 5, 6. Suppose if I write like this, so number of rows are what? 3. And number of columns are what? 2. These are the two examples here. And the next third one. Okay. Now you see here what I'm going to write here, column matrix. Column matrix, you know very well that only one column. Okay, a matrix is said to be column matrix if it is contain only one column. One column, I said, right? It will be like this 1, 2. Okay, one example 1, 2, 3. Suppose if I write here, this is column matrix, right? Come to the next one now. Okay, fourth one you see here. Here, row matrix. Row matrix. Row matrix means, okay, a matrix is said to be a no matrix if it contain only one row, right? Like this, 1, 2, 3. Example, right? 5, 7, 9. No comma, nothing, Nana. Please remember, nothing is there in between. Just you have to write a little gap is enough, right? This is row matrix. Now come to the next one, fifth one, right? Singleton matrix. What is that? Singleton. Right? Singleton, Nana. Singleton, not turn. Turn matrix. You can say that. matrix. Singleton matrix means, you know very well, only one element if it is there, one by one matrix, you can call it as singleton matrix, you can say. And the next one, sixth one is what? You can say that here you should know that null matrix. Okay, null matrix. What is that null matrix means? Or whatever it may be the order of the matrix, if it contain all zeros, you can call it as null matrix. A matrix is said to be what? Null matrix, right? Whatever it may be, row or columns are there, number of columns, number of rows are there. If it contain all zeros, the question is if it contain all zeros, we can say that null matrix. Now come to the next one, 7-1 now. Rectangular, right? Rectangular matrix. Right, rectangular matrix. Here, a matrix is said to be rectangular if the number of rows are not equal to number of columns. Number of rows should not be equal to number of columns. Nana. That is called as what? Row matrix. For example, 1, 2, 3, 4, 5, 6. If I write here, you see that number of rows are what? 2 and number of columns are 3. This is what? Rectangular matrix in brief. Right, another one I can write here 1, 2, 3, 5, 6, 7. If I write like this, even though if you consider this as 0, chalega, this is what? 1, 2, 3. 3 rows and 2 columns. Number of rows should not be equal to number of columns. Anybody have any doubt? Shall I move on to the next?
Yes, sir.
Okay. Okay. Now you see here, Nana, next one is, 8th one is square matrix. Square matrix. In the case of the square matrix, a matrix is said to be a square matrix. Okay, number of columns should be equal to number of rows. Right, number of columns or number of rows is equal to number of columns. You can say that 3, 4. See here, 2 by 2 matrix. Suppose if I write here 1, 2, 3, 4, 5, 6, 7, 8, 9. If I write, this is what 3 by 3 matrix. These are what? Square matrices. Right, Nana? These are square matrices. Now come to the next one, Nana. 9th one is most important one. What is that principal diagonal of a square matrix? Okay, principal diagonal. Okay, of a square matrix. Okay, square matrix. Principal diagonal of a square matrix. In a square matrix, what I am saying here, you see this, Nana. In a square matrix, right? You take any square matrix here. Example, I take 1, 2, 3, 4, 5, 6, here 7, 8, 9. Some numbers take it. Okay, I want to say one thing here very clearly. What is the definition here? In a square matrix, the diagonal from first row, you see this is first row. First row to first row of the first element to last row of the last element. That means it will be like this, red line. This is called its principal diagonal. Right, if I write here like this, Nana, 3, 4, 5, 6, and this is your principal diagonal. Let me finish the matrix here. It will be principal diagonal, you can say now. Next one is what? 10th one. You see this, Nana. What is that? Diagonal matrix. Okay, diagonal matrix. Diagonal matrix. A square matrix is said to be a diagonal matrix. What? A square matrix. It should be a square matrix. And said to be a diagonal matrix if all the elements are 0 except principal diagonal elements. That means suppose if I write like this, A0, 0, 0B0, 0, 0, C, if I write, A, B, C are not 0 Nana at that time. So this is called what? Diagonal. Otherwise, simply if I say like this, 4, 0, 0, 0, 4, 0, 5, 0, 0, 0, 6. If I write here, authentically I can say that this is more powerful than this. What is ABC? If you say that 0, 0, it is not a diagonal. If ABC are not zeros, then only it is diagonal matrix, you can say it. Right, after this one. Now move on to the next one, 11th one. See here, scalar. Scalar matrix. Scalar matrix means what? You see, a diagonal matrix is said to be a scalar if all the principal diagonal elements are what? Same, Nana. So for example, if I take like this, 0, 0, 2, yeah, you can say that not, it is a scalar matrix. Okay, a square matrix A is said to be scale. Okay, a square matrix A is said to be scalar matrix if all the non-diagonal elements are what? Non-diagonal elements are what? Zeros, and diagonal elements are what? Equal. Same. It should be what? Like this. You can say that scalar matrix. Now, after this one, guys, 12th one is one of the most interesting one. That is what trace of a matrix. Trace of a matrix. Right. What is that? Trace of a matrix means what? You see here, it is possible only in the case of what square matrix. Right. For example, here A, if I said that trace of A means sum of the principal diagonal of a square matrix. Sum of the principal diagonal elements of a square matrix is called its trace. What is the trace of A means what? 5 here. You can say that 5. Now come to the next one. B, second example I'm taking. 1, 2, 3. Right. Right, 0, 5, 6, 0, 0, 7. If I said like this, yeah, definitely. Trace of B. Right. What is that, Nana? Trace of B is trace of B. Trace of B is 1 plus 5 plus 7. This is principal diagonal elements. That is what 13. This is trace of B. Hope so that you understood, Nana. Right? Trace of the matrix you understood. Now come to the next one. Here I am going to introduce third one. Right? What is that? See this, guys. 13th one is upper triangular matrix. Upper triangular. Upper triangular matrix. Okay, upper triangular matrix means what? See, the condition is if you indicate a matrix as what, like this, Nana, Aij, I for row, J column, right? Some n by n matrix, right? Take down like this. And remember, I and J, Aij should be what? Greater than, Ai should be what? 0, Nana. All Aij's are what? 0 if I is greater than J. This is a condition. I is greater than J. Right, I is greater than J. That means you need not worry. You see here 1, 4, 5, 0, 7, 6, 0, 0, 8. If I write like this is called upper triangular matrix. What is the mathematical condition? I should be, row should be greater than column. Then all the elements are what? Not zeros. And the rest of all elements are what? Zeros now. Simply I can say that Aij is 0 if I is greater than J. The below the leading diagonal, whatever the elements are there, are zeros now. It is like this. Okay, shall I move on to the next, guys? Okay, now here 14th one. See this lower triangular matrix. Lower triangular matrix. Lower triangular matrix. Right, each and every point I'm discussing. A square matrix A is said to be lower triangular if all the elements above the leading diagonal are 0. Simply I can say like this, Nana. What is the condition? Suppose if for Aij, here Aij is 0, but this time I should be less than J, Nana. So it means like this. One of the example 1, 0, 0, 2, 0, 1 minute. Here I can write like this 2, 3, 0, 4, 5, 6. See here, principal diagonal above whatever the elements are there are 0. Simply you can say that this is right. So triangular matrix is over. Now the next one is the 15th one. Right? Here we have to go for submatrix. This is also what acting as a major role. Submatrix. What is a submatrix? You see, submatrix means, okay, a matrix which is obtained from a given matrix. A matrix which is obtained from given matrix by deleting any number of rows and any number of columns called submatrix. Suppose if I said like this, 2, 3, 4, 5, 6, 7 is a given matrix. Right. What are the submatrix here? Means so many submatrix we can write. A1. You see here, I deleted second row, 2, 3, 4. This is submatrix. Okay. B1, if I said here, 5, 6, 7. Yeah, I deleted first row. If not, you can go for second one. I deleted the rest of all, only 2, 5. I'll take like this. Here, B2, if I deleted here first column and second column, 2, 5, 4, 7, if I write, yeah. So many are not only this, Nana. C1, if I said 2. Single elements also there. That means 3 category of matrices, sub matrices are possible. Row matrices, column matrices, 2 by 2 matrices, not 3, 4, and singleton matrices are possible here. These all are called what? It's submatrix. Right, come to the next one. 16th one, you see these guys, equal matrices. Equal matrix. Equal matrix means two matrices are said to be equal when if the order is what same and the corresponding elements are also what same, then only you can say that equal matrices. Suppose if I said that A, B, C, D, what is the order here? 2 by 2. Okay, if these two are equal, 1, 2, 3, 4, so there is no doubt that their order is same, right? And the corresponding element A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. After this class, you shouldn't have any kind of doubt now. That is my intention. And my intention is very clear. Neither in theory nor in problems you should have any doubt. It's a final preparation for that's why I don't want to leave any kind of definition also. Right, come to the next one. Now 17. After this one, you see this guys. Yeah, 17th point is, see this one, addition of matrices. Okay, addition of matrices. Even though the student who doesn't know anything about matrices is going to learn everything is clearly, right? So what you have to do, addition of matrices is possible only for same order matrix. Same order matrix are there, addition of matrices are possible, otherwise not possible. You see, suppose if I said it to you like this, Nana, 1, 2, 3, 4, right? B is equal to, suppose if I said here 3, 5, 6, 7, and C is equal to, you see this one, Nana, here if I said that 1, 2, right, 1 and 2, if I gave you like this. Suppose if I said A plus B, possible means yes, their order is same, yeah, we can add. How? What? Like this, corresponding elements we have to add 2 plus 5 and 3 plus 6, 4 plus 7. And you see, suppose if I said that A plus C is possible means, yeah, you can say that not possible. Why? Their order is not saying this, why not possible, simply you can say. Right, addition of matrices is like this. Even, okay, now come to the next one, Nana. Here I gave you that clear idea about this and the theory and as well as all the problems I have to discuss, Nana. Right? So the next one is, see Nana. Here in the next page, I want to give this one, properties of addition. What is that? 18th one. See this? Properties. Properties of matrix addition. Matrix addition. Okay, properties of matrix addition. What is that? See here, if I said that A plus B, yes, it is B plus A is also possible. This is commutative law, Nana. Suppose if I said that A plus B plus C is equal to A plus B plus C. Yeah, it is associative, you can say. Right, come to the next one. Right, what is that? A plus O. O means, you know very well that null matrix. O plus A. Yeah, you can write like this. Identity. You can say that O is identity here. Now, if I write here A plus B is equal to 0, B plus A. Sorry. Compulsory here. Clearly, B is what means minus A. Minus A. Okay. B is what? Minus A. Right. So simply I can say that additive inverse. What is the additive inverse of A means minus A. So simply here I can write here additive. Additive inverse. Inverse of A is what? Minus A. Suppose A is equal to 1, 2, 3. Right. You know very well that minus A means you have to multiply minus to each and every element of the matrix Nana. Every element, whatever it may be, the number of rows are there, you have to write like this. This is one of the example. Right. Now the next one is here 19 point is you are supposed to learn this one, scalar. I understood. Okay, I noticed that in some cases, right, student will get confusion in the case of what determinants and matrix multiplication, scalar multiplication of matrix. Suppose scalar multiplication of matrix means any matrix is given here 1, 2, 3, 4. Suppose here I have taken here lambda A. If I said, yeah, lambda you are supposed to multiply to all elements of the matrix. Right, don't get confusion. Only you have to multiply per column or only multiplying per row. Not like this. In matrices, you have to multiply to each and every element. But in a determinant, it should be applicable only for row or column. Okay, that's why you have to be clear in this case, Nana. This is 19th one. One of the point you please remember. Suppose K of A plus B matrices, then you can write Ka plus Kb also you can write. Right. Suppose if I write minus Ka, yeah, you can write like this also. K of minus A or K of minus A also you can write. Anything is possible. Okay. Subtraction of matrices means you know very well that it's not a big issue. It's a very simple one. Okay. Subtraction of matrices is also there. Okay. Subtraction of matrices. Subtraction of matrices, you know very well, A minus B. You take same order matrix and subtract, we'll get the result for that one. Okay, I'll move on to the next one, Nana. 21. What is the product of two matrices? This is the different one. Product of two matrices. Two matrices. You see this one. This is more important, guys. Those who are new learners, for them it is useful. For those already knows, you just glance this one more than enough. Right. See, if A and B two matrices, if you select, right, A and B are two matrices, two matrices. AB is possible only, AB is possible, see Nana, AB is possible only if the number of columns, if you write like this, 2, 3, and B should be what? 3, 3, 2, 3, 1, if it is like this, chalega. So number of columns in first row, first matrix should be equal to number of rows in second matrix. The result of this matrix is what? You will get 2 by 1 matrix. The left out whatever is there like this. For example, if I take here 3, 4, if I take 3 by 4 is there. Here 4 by 2 if I take like this. Then AB order is what, Nana? Yeah, it is possible. Yeah, possible. That is what 3 by 2 you are going to get. Right? Like this, it is possible. Number of, what is the rule here? Number of columns in a first matrix should be equal to number of rows of the second matrix. Then AB is possible. This is the one. And the next one is here. You see this, Nana. After this one, what are the rules of this means? You remember AB never be equal to BA, Nana. Why? Because see here, suppose if I take here 2 by 1, B is equal to 1 by 2 if I take. So AB should be what, Nana? 2 by 2 matrix. But you write reverse, B 1 by 2 matrix, A 2 by 1 matrix. You see that even though AB is exist here, the order of this matrix is 1, the order of this matrix is 2 by 2. Will they equal? Never. So that's why, sir. Okay, that's why, sir, it is. That's why I said it to you that it is not. And the next one is, but second point you see this, Nana. ABC is equal to ABC. Associative law is exist here. ABC. Associative law is going to be exist. And the next one is distributive laws also going to be exist, Nana. A plus B is equal to AB plus AC. It is also going to be exist. And AI, if I write, A you are getting, it is identity. Right, it is identity. So please remember that. And now here, one point we missed it. Okay, what is that, Nana? Trace of a matrix. Right, trace of a matrix means I said it to you that just sum of the principal diagonal elements. Right, you please remember, suppose if I said that Aij, n by n matrix. Right, what is trace of A? How you are going to write? See, Nana, how your trace of A means you are supposed to write sigma. See this sigma, I is equal to 1 to n. But remember, here, Ij if I write, what is this? It will be like this, A11, A1, A22, yet A22. This is the one, Nana. A33, like this. How? ANN. You have to write like this, ANN. Right? This is what? Trace of a matrix. What are the properties of trace? What are the properties of trace means? See here. Properties. Properties of trace of a matrix. Trace of a matrix. Properties of trace of a matrix, Nana. So this is 21 point and 22nd one is this one and 23rd one is this. Okay. Now the question is here, you see this trace of Ka. is equal to k into trace of A, you can write. Right? Trace of AB, trace of A plus B. If you say trace of A plus trace of B, trace of B. And you remember trace of AB, people are going to write trace of A into trace of B. This is absolutely wrong. Trace of BA is correct. You can't write like that, Nana. And you remember here, trace of IN. What is that means? N. Nothing. N, that's it. But you remember here, trace of AB is not equal to trace of A into trace of B. Absolutely wrong. Right? This is one, another property of trace. Now we'll move on to the next one, guys. What is that? Some rules are there, Nana. 24th one. See, guys, in multiplication, idempotent. Okay, idempotent matrix. Anyone have any doubt? Anyone have any doubt, guys? Savan Garu? Am I?
No, sir.
Right. Fine. Okay. Now you see here, idempotent matrix means very simple, Nana. A square matrix A is said to be idempotent if A square is equal to A. Right? A square is equal to A. Wherever that go for multiplication of two matrices should gives us what? Same result. So here one example is there. I want to give like this. If you have free time, you please check it out. If you go for squaring, you will get what? Same result, Nana, for this matrix. 1 minus 2, 3. Right. I don't have much more time. So go to show you that A square, if you do, definitely you will get A only here. Okay, like this. Idempotent. After this, periodic. See this, Nana, periodic. Periodic matrix. Right? Periodic matrix means a square matrix A is said to be periodic. Okay, periodic. Where K is A to the power of, if, you see this, Nana, if this rule should be exist. A to the power of K plus 1 is equal to A. Where K is what? Least positive integer. K is least positive integer. Positive integer, Nana. Least positive integer, then you can say that. One of the example I want to give here, see this one, 2, 5, 14, and 1, 3, 8, and minus 1, minus 2, and minus 6. If you take, then definitely A to the power of 4 is equal to A you will get, and the value of K is equal to what, Nana? 3 here. Right, I don't have much more time, guys. That's why I'm giving you like this. Right, we discuss idempotent and we discuss here periodic matrix. Now the next one is nilpotent matrix. Nilpotent matrix. Nilpotent matrix means what, Nana? See, if you go for this, a square matrix you take down and you multiply several times, k times, and you got it what? 0. Right? Maximum guys, in intermediate level, 3 possibilities. A cube, till A cube, there is a chance. For example, here I would like to give that example here. 1, 1, 3, familiar example, everybody knows this. 5, 2, 6, and minus 2, minus 1, minus 3, if you take, and go for 3 time multiplication, yeah, you will get what? 0. So what is the nilpotent, what is the order of the nilpotent matrix? Means 3. The way A is called what? Positive integer, Nana. K is always, remember that, positive integer. Right? A to the power of K is equal to 0. Here, 3 times if you multiply, K is equal to 3. Right? Sometime what happened? 2 times also if you multiply, you will get what? 0. Right? Okay. Now come to the next one. Nilpotent after this, involutory. Involutory matrix. What is that involutory matrix? A square matrix A is said to be involutory matrix if this condition exists. A square is equal to I. Right, Nana? A square is equal to I. Here also I want to give one example. Okay, in your free time, you just check it out. You will get what? 0. Right, 3, 5, 0. Here 1, 2, minus 1. Yeah, you see this one. It will 0. And if you go for squaring, definitely you will get what? I. A square, if you go for it, you will get what? I. This is called involutory matrix. 3 definitions I have given. One is what? Idempotent, A square is equal to A. Nilpotent, A square is equal to A to the power of M or A to the power of K is equal to 0. That is what nilpotent. Another one is what? Involutory. In the middle of this one, periodic. It is similar to idempotent matrix, Nana. So I can't say like that, but periodic means, a to the power of k plus 1 is equal to a should get. K is what? Positive integer, least positive integer you have to say here. This is integer. Okay. Now the next one. Now we'll move on to the next one. After this one, with the help of matrix multiplication, we come across till here. Now the next one is transpose. See guys, transpose. देख भाई, transpose of a matrix. प्रॉब्लम करते वक्त बात करेंगे यार. अभी तो थियरी चल रहा, खाली बता देता हूँ, जल्दी जल्दी खत्म हो जा रहा. Right, transpose of a matrix. What is the transpose of a matrix means? Suppose if a matrix is given like this, Nana, Aij, right, m by n order, the transpose of A is denoted by A transpose or A dash, and it can be written as AJI, Nana. That means n by m. Okay, if you interchange the rows, of a given matrix into columns, the resultant matrix is called as what? Transpose of a given matrix. Right, there are some rules are there. You please remember, guys, rules are there, and the rules are this. A transpose whole transpose is A plus or minus B whole transpose is what? A transpose plus or minus B transpose. And the next one here, Ka transpose is there. It is not applicable for that. K into A transpose you can write. Suppose AB whole transpose, if it, be careful here, B transpose, A transpose you are supposed to write. And sometime what happened, A transpose whole to the power of n is there, or A to the power of n whole transpose if you write, that is also as clear now. So very simple example I want to take here, 1, 2, 3, 4, suppose example, A transpose is nothing but here, transpose 1, 3, 2, 4. I hope so that you people can catch easily. Now here two more definitions are very, very important in the case of after transpose, Nana. For mains, it is more important. Symmetric matrix. Symmetric matrix. A square matrix A is said to be symmetric if you remember, guys, A transpose is equal to A. Sir, is one of the best example which I want to tell you, that AHG, right? HBF and GFC. Yeah, I hope that everybody can remember this for a long time. I can say that whole life also. You remember like this, a hefty girl, you add just one word here, with a boyfriend goes for coffee. Right? These are the words if you remember. So for a long time you can remember. See this one. HS is same, G same, and F same, and the diagonal elements are different. In the middle of the diagonal, some element may be 0, chalega. Okay, move on to the next one. Skew symmetric matrix. I can't take any risk in this one. That's why I'm going in detail. Right, in detail. जल्दीबाजी करके खत्म करना नहीं है भाई. Right, पूरा डिटेल में बताना है, इसलिए ऐसा कर रहा हूँ. Right, a square matrix A is said to be skew symmetric matrix if A is equal to A transpose is equal to minus A, or A is equal to minus A transpose. ऐसा बोल सकते हैं. It will be like this. इसके लिए बहुत सिंपल है फंडा. देखो, all principal diagonal elements are what? 0, Nana. Suppose 2, 3, 4, if you write here, same as it is, but negatives. Minus 3, minus 4, you have to write. This is one of the easiest way. But one thing you remember, what is the logic here? Why we are supposed to, give top priority means any matrix you can express as sum of symmetric and skew symmetric matrix. देख भाई, A plus A transpose. Right, ये होगा half A minus A transpose. Any matrix, this is what? Symmetric, and this is what? Skew symmetric. 1 by 2 है, ये skew symmetric. It's skew symmetric. See देख, अब यार यहाँ पे सीधा सीधा देखो यारो, ये मैं skew symmetric ऐसा बोल रहे क्या है? डेफिनेशन को देख के A ट्रांसपोज इक्वल टू ये है, ऐसा नहीं यार. इसको C ले ले यार, इसको ट्रांसपोज अप्लाई कर ले भाई, A ट्रांसपोज हो जाएगा. देख यार, A ट्रांसपोज होल ट्रांसपोज क्या होगा यार? A ट्रांसपोज प्लस A होगा. इसलिए मैं इसको बोला कि सिमेट्रिक मैट्रिक. Why I said this is symmetric? Very simple, Nana. You take this total, even though 1 by 2 is there or not there, doesn't matter. This is more important. The structure is important. So if you go for transpose, what you got here, Nana? C transpose is equal to See, you got it. That's why I said that it is symmetric. In the same fashion, if you go for something D, you will get what? D transpose is equal to minus D you are going to get. That's why it is what? Skew symmetric matrix. यार यहाँ पे देख लेना यार थोड़ा बहुत अच्छी तरह से. Right? Skew symmetric and this one. Now come to the next one. यहाँ मेंस के लिए थोड़े पॉइंट्स हैं आपको, वो बताना चाह रहा था मैं. क्या पॉइंट्स है यार? मेंस के लिए मैं थोड़ा गैप दे रहा हूँ यहाँ पे, थोड़े पॉइंट्स है. जैसा कि ए बी आर सिमेट्रिक, फॉर एग्जाम्पल देख भाई, ए बी आर सिमेट्रिक है. राइट, ए बी आर सिमेट्रिक मीन्स यू रिमेंबर दैट ये दो भी सिमेट्रिक है, समझो यार. सिमेट्रिक यहाँ पे देखो यार, ए प्लस आर माइनस बी क्या होता, और ए बी प्लस बी ए बी है, ये दो भी सिमेट्रिक हो जाते हैं यार. ए प्लस आर माइनस बी और ए बी प्लस बी ए बोथ आर व्हाट सिमेट्रिक हो जाएंगे. अगर से आप लोग ऐसा बोलोगे, फॉर एग्जाम्पल ए बी माइनस बी ए लोगे तो क्या होगा? कुछ नहीं यार, ए स्क्यू सिमेट्रिक हो जाएगा. स्क्यू सिमेट्रिक होएगा. राइट, स्क्यू सिमेट्रिक हो जाएगा भाई, ये होता है ऐसा. ए बी आर अगर से देख भाई, ए बी आर स्क्यू सिमेट्रिक मैट्रिक्स है, स्क्यू सिमेट्रिक है, प्लीज रिमेंबर स्क्यू सिमेट्रिक है. तो यार ये प्लस आर माइनस बी और ए बी माइनस बी ए बी स्क्यू सिमेट्रिक होएगा. राइट, ये थर्ड पॉइंट है. सेकंड पॉइंट में इसका ही दे दिया, इसके दो पॉइंट आ गए, ए पॉइंट एक है, ए पॉइंट ए है, एंड दिस इज व्हाट थर्ड पॉइंट इज दैट. नाउ कम टू द नेक्स्ट वन. ये पॉइंट याद रखना है भाई, ए बी सिमेट्रिक रहा तो ए प्लस आर माइनस बी और ए बी प्लस बी ए सिमेट्रिक ही होगा, और ये स्क्यू सिमेट्रिक हो जाएगा. लेकिन ए बी स्क्यू सिमेट्रिक रहे तो ये दो कंपलसरी स्क्यू सिमेट्रिक ही होता है. चलो अभी नेक्स्ट देखेंगे. व्हाट इज दैट? ऑर्थोगोनल. ऑर्थोगोनल मैट्रिक्स. राइट, ऑर्थोगोनल मैट्रिक्स में क्या है? व्हाट इज दैट? ए स्क्वायर मैट्रिक. यहाँ पे भी स्क्वायर मैट्रिक का है यार फंडा. देखो, ए स्क्वायर मैट्रिक ए इज सेड टू बी ऑर्थोगोनल इफ ए इंटू ए ट्रांसपोज इक्वल टू ए ट्रांसपोज ए इज इक्वल टू आई. जब हो रहा देन इट इज कॉल्ड व्हाट? ऑर्थोगोनल मैट्रिक बोल दे सकते. एग्जाम्पल देख भाई, यहाँ पे 0 2 बी सी, राइट, ए बी माइनस सी. तो जब मल्टीप्लाई करेगा तो आ जाएगा ए माइनस बी माइनस सी, ऐसा रहेगा. ये क्या होगा यार? ये ऑर्थोगोनल मैट्रिक हो जाएगा. राइट, ये ऑर्थोगोनल मैट्रिक हो गया. यार अभी देखो नेक्स्ट वन देखो यार, ये ऑर्थोगोनल मैट्रिक तक यहाँ तक पहुंच गए. ये क्या है? फर्स्ट पार्ट ऑफ मैट्रिसेस खत्म, यहाँ तक फर्स्ट पार्ट इज फिनिश. अब यहाँ से स्टार्ट होता क्या यार? पार्ट 2 स्टार्ट होता. राइट, पार्ट 2 इज गोइंग टू स्टार्ट हियर आफ्टरवर्ड्स. पार्ट टू क्या है भाई? डिटरमिनेंट्स है. डिटरमिनेंट ऑफ ए स्क्वायर मैट्रिक. यहां से देख भाई, डिटरमिनेंट ऑफ अ स्क्वायर मैट्रिक. डिटरमिनेंट ऑफ ए स्क्वायर मैट्रिक क्या आएगा? See guys, if you take 2 by 2 matrix A B C D, determinant of A is denoted by like this, Nana, and we are going to write like this in this way. This is denoted in this way. And how we are going to define cross multiplication? AD minus BC. And people are going to write like this also. Det A is equal to in this way, det A. Like this. But you see, 3 by 3 matrix if I take, for example, 3 by 3 matrix if I take, if A is equal to det A, I directly I would like to take in this way. See this A1, B1, C1, A2, B2, C2, A3, B3, C3. For learners also, this theory gives clarity ना, right? इसका वीडियो जब आएगा ना तो इसको सब थोड़ा एडिट करके आपको मैं बता दूंगा. यानी कि this vertical line सीधा ड्रॉ नहीं कर रहा हूँ. Exactly this should be what? Vertical ना. I don't have that much of time, that's why. Here let us expand this one by row. First row से expand कर लो by row, expanding with row 1. तो A1 ले ले भाई, क्या होगा देख, B1 C2 B3 C2. You leave that row and column, whatever is left out, that you take into mark. And you please follow this rule: plus minus plus, minus plus minus, प्लस माइनस प्लस. अब ये रूल कहां से आ गया यार? यहां से ये डिटरमिनेंट से पहले आपने को 2-3 बातें रह दे, माइनर एंड कोफैक्टर. राइट, देख भाई, अगर से मैं लिख दिया 1 2 3 4 5 6 -1 0 -2 कुछ ऐसा लिखा. माइनर बोला समझ में यार, माइनर ऑफ एन एलिमेंट बोलते हैं इसको, 1 बोल के लिखा. तो क्या होता 5 6 0 -2 ऐसा होगा. उसको M11 बोल के लिखते, M11 ऐसा होता. M12 बोले तो सेकेंड एलिमेंट का माइनर, वो क्या होगा यार 4 6 -1 -2 ऐसा होगा. राइट, ऐसी जीरो का भी माइनर रहता. M32 बोला समझो, M32 बोला जीरो का माइनर, वो क्या होगा यार 1 3 4 5. After deleting, see for example 1, I deleted this row and this column and this row. This row I deleted, this column I deleted, whatever the left out one I have taken as a determinant. And this is what our minor for what 1. And the second one, suppose if I take second one, guys, I deleted this and this, and the left out one is 4 6 -1 -2. Yeah, that's why I've taken here. 0 if I take here, yeah, I deleted like this now. I removed this 2 and whatever the left out one is there, 1 3 4 6 4 6 1 3 4 6 is a right, 1 3 4 6 is a minor, you can say, right. And cofactor, if I say the same element, cofactor means what? A11 we are going to denote with capital letters now. How it is going to be written, Nana? -1 to the power of 5 plus j mij. This is the formula. Right. What is that? Here, for example, first element if I take -1, it belongs to which row? First row, first column. So that means 1 plus 1 I have to write. Right, 1 plus 1 I have to write, and afterwards, and you know very well that after that you have to write mi. 0 -2 you have to take. Okay, bye. I hope that you people have followed this. Am I? समझ में आया ना? Sophia?
Yes, sir.
Okay. Now the next one. Next, like that we did it, Anna. So that's why while expanding the determinant, right? While expanding the determinant, what I'm doing here, while expanding the determinant, here, same as it is, but the next one is minus. You will get what like this, Anna. We'll understood these all things here. If you expand, plus, minus, plus, minus, plus, minus, plus, minus, plus, you'll get. That's why when you are going to expand here, first row, you have to take like this. A2, C2, A3, C3. Right, and C1. This is what A2, B2, C3, A3, B3. Right, if you expand, whatever you'll get, that is your answer. But the rules of determinants are very, very important, right? बहुत अच्छे rules है यार, वो जरा देख लो. A transpose क्या होगा यार? Det A भी हो जाएगा. So suppose AB det of AB is nothing but det A into det B, you can write, right? And you remember KA अगर से कुछ दे दिया ऐसा तो क्या होगा यार, एक K को कितने बार लिखना है इसका ऑर्डर पे डिपेंड करता. If A is n by n order, तो n times you have to write det A, ऐसा लिखना पड़ेगा आपको. अब वही बात बता रहा था मैं. And next one, det A to the power of n can be written as det A to the power of n, you can write here like this. हाँ, अभी यहाँ पे थोड़े रूल्स है, वो रूल्स मैं बता देता हूँ, जरा देखो यार. Here 1 2 3 4 5 6, right? -1 0 -2. The moment I expand, this is matrix, and that if I gave you like this, now you see this. So 1 2 3 4 5 6 -1 0 -2. The moment I am expanding here, right? The moment I am expanding this, yeah, I'm getting out like this, Nana. Okay, the rule, whatever I said to you, na, that rule, based on that rule, let me expand here. So first one ले लिया यार, row 1. By row 1 I'm expanding. Here by row 1, if I'm expanding here 1, and this is what -10, you're getting -2 आता. Next one क्या होता देख भाई, -8 plus 6 आ रहा, 8 -8 plus 6 आ रहा. And come to the next one, 3 आए तो 0 and plus 5 आ रहा. So what is the result? Result is what? Some 9 you are getting. You expand along with any row, any column, but you will get the same row, same result. So यहाँ पे देखो यार, ये 4-5 पॉइंट अच्छी तरह से याद रखो. Suppose a determinant contain one complete zeros. 6 minus 1, 2, 3. If it is like this, the result is 0. A determinant contain one column is 0. 1, 2, 3, 4, 5, 6. The result is 0. This is second point. And the third point is, देखो भाई. For example, 1, 2, 3, 1, 2, 3, 4, 5, 6. Two rows are equal, result is 0. Right, two columns are equal, 2, 3, 1, 2, 3, 1, 2, 3, 2, 4, 4, 5, 6. If I write like this, it is also 0, fourth one. Or else you can say like this, 1, 2, 3, 2, 4, 6, 7, 8, 9. If I write, it is also 0. One is proportional to other one. Right, row, two rows are what? One is proportional to other. Sixth one देख भाई, 1, 2, 3 ऐसा लिखा, 2, 4, 6 ऐसा आया, 7, 8, 9. If I write like this, the result is same. This is what two columns are proportional here. That's why the rule is 0. Right. हाँ भाई, अब बात आती है यार some rules की. इसमें करने वाले रूल जो रहते हैं ना, वो देखो क्या होगा. Suppose here what I am doing here, see this na, the determinant which I have taken here, 1, 2, 3, 4, 5, 6, minus 1, 0, minus 2, and the result I got it as 9. You know very well. ये result 9 है, इसका result 9 है. तो मैं अभी कर रहा हूँ क्या? देख भाई, मैं इसको क्या कर रहा हूँ, C2 को ले लिया. यस, C2 को लिया. C2 को लेके मैं क्या कर रहा हूँ, देख यार, C2 minus C3 करा समझ. C2 minus C1, चल जान दे, C1 करेंगे. C2 minus C1 करा तो क्या हो रहा, सबट्रैक्ट कर रहा तू, राइट. C1 माइनस यहाँ C2 माइनस C1 करा तो बनता क्या है भाई, 1, 4 माइनस 1, 1, 1, 1 हो जाएगा. 3, 6 माइनस 2 रहेगा. इसको एक्सपैंड कर ले, वो भी 9 आएगा. एनी ऑपरेशन वॉट एवर इट मे बी, यू विल गेट व्हाट सेइंग. फॉर एग्जाम्पल अगर से तू ऐसा करा समझ, 8th वन ऐसा बता रहा हूँ, 8th वन C2 ले लिया, C2 माइनस 2 C1 करा, और C3 ले लिया, C3 माइनस 3 C1 करा. मतलब तेरा इंटेंशन बहुत क्लियर है कि दो एलिमेंट को जीरो बना रहा, 2 and 3 को जीरो बना रहा. तो कर रहा क्या, 1, 0, 0, ओके, 4, 5 माइनस 8, 6 माइनस 12 हो जाएगा. यहाँ पे देख भाई, माइनस 1, 0 माइनस 2, 2 माइनस 2 प्लस 3 हो जाएगा. राइट, इसका भी एक्सपैंड कर ले यार, नहीं आएगा. वॉट एवर यू डू इट्स सेम. Any kind of column operation, any kind of row operation, definitely you are going to get the same result. So column operation तो बता दिया यार, row operation से और एक example बता दो. देख 1, 2, 3 है, 4, 5, 2, 4, 6 है, राइट, ये तो बता दिया था अभी. 1, 2, 3, 4, 5, 6, माइनस 1, 0, माइनस 2 था. ये मैट्रिक्स है अपना. अगर से इसमें मैं ऐसा दो रोज, ये दोनों को जीरो बना रहा हूँ. ओके, R1 कैसा बनता देखिए यार, R2 माइनस 4R1 ये बन गया 0. देख यार, R3 है, R3 प्लस R1 करा, वो भी 0 बन गया. तो आएगा रिजल्ट क्या यार, देख 1, 0, 0, 2, 5 माइनस 8, देख भाई 2 यहाँ पे आ जाएगा. 3, 6 माइनस 12, ये भी 1 हो जाएगा यार, राइट. ऐड करा ना 3, ऐसा इसको एक्सपांड कर ले, वो भी 0 हो जाएगा, वो भी 9 आ जाएगा. So any row operation, any column operation, nothing is going to happen. It is same. Determinant का एक पूरा रूल है, आप लोग को अच्छी तरह से आना चाहिए. And the next one is here, 1, 1, 3. I have taken like this. Sorry, 1, 2, 3. I'm supposed to write here 1, 2, 3, 4, 5, 6, minus 1, 0, minus 2. I have taken this. And now if I split this okay, determinant in this way, 1, 2, 3. What I'm writing, 1 plus 3, right? 1 plus 4, 1 plus 5. Suppose if I split like this, minus 1, 0, minus 2. How can I split this means? Yeah, it is 2 determinant. 1, 2, 3 एक हो जाएगा, 1, 1, 1, minus 1, 0, minus 2. यार इसको देखो, 1, 2, 3, यहाँ पे 3, 4, 5, minus 1, 0, minus 2. इसको जो भी एक्सपैंड करेगा ना, इसका रिजल्ट भी क्या होगा यार, 9 ही आएगा. The result of this one is what? 9 only. We cannot. Okay. So this is also one of the rule. यहाँ तक हो गया. अब next बचा क्या यार, second part में देखो यार, here adjoint. This is one of the most important भाई. Okay, adjoint. Adjoint matrix. Adjoint matrix is what? What is the meaning of adjoint matrix? See, suppose if I write like this, Nana. A1 B1 C1 A2 B2 C2 A3 B3 C3 ऐसा ले लिया है, राइट। एडजॉइंट ऑफ ए क्या होगा यार, देखो ये होगा एडजॉइंट ऑफ ए, इफ आई राइट लाइक दिस A1 A2 A3 B1 B2 B3 C1 C2 C3 ऐसा लिख रहा हूँ। व्हाट इज दिस, ऐसा कैसे लिख रहे हैं सर, अब कैसा आए, ये कुछ गड़बड़ करने की कोई बात नहीं है यार। पहले क्या लिखना पड़ेगा इसको, को फैक्टर, देख क्या को फैक्टर ऑफ ए बोल के लिखना, लिख के क्या करना, देख 9 बॉक्सेस यू हैव टू राइट। हाउ मेनी, 9 बॉक्सेस। Rule I am explaining here. You write 9 boxes, plus, minus, plus, minus, plus, minus, plus, minus. You write and fill up the boxes. How? Like this. For example, if you want to fill up this one, remove this row and column, whatever the left out is there, that B2 C3 minus B3 C2 ऐसा आता। Suppose if you want to fill up this one, ये निकाल दे भाई, ये भी ये निकाल दे, क्या आता तेरे को यहाँ पे A1 C2 minus A2 C1 आएगा, ये इसमें ऐसा फिलअप करना पूरा करके क्या करना। अब देख यार, इसको एडजॉइंट ए जब बोलेगा तू तो नहीं, एडजॉइंट नहीं, इसको क्या होगा, इसको मैं क्या कर रहा हूँ, ऐसा पूरा फिलअप करेंगे वाले को, पहले क्या कर रहा हूँ बोले तो ऐसा लिख रहा हूँ, को फैक्टर, बता रहा हूँ आपको, को फैक्टर ऑफ ए, व्हाट इज दैट, आई वांट टू रिप्लेस लाइक दिस A1 A2 A3 B1 B2 B3, आई एम नॉट राइटिंग दिस ऑल वैल्यूज, सम वैल्यूज आई एम राइटिंग लाइक दिस, इंडिकेटिंग C1 C2 C3 ऐसे लिख दिया यार। अभी देख यार, एडजॉइंट ए जब बोल रहा हूं तो ये कोफैक्टर ऑफ ए का ट्रांसपोज लिखना है भाई, इसका ट्रांसपोज यही होगा, उसलिए एडजॉइंट बोल के ऐसा लिखा। इसका पूरा वर्किंग रूल भी आपको समझा दिया। बट वन थिंग इज वेरी क्लियर नाउ, व्हाट इज दैट, दिस इज मोर इंपॉर्टेंट एंड वन शुड नॉट फॉरगेट अबाउट दिस। व्हाट इज दैट ना, पहले वाला देखो रे, ए इंटू एडजॉइंट ए इज इक्वल टू डेट ए इंटू आई, राइट। और ये भी हो जाएगा एडजॉइंट ए इंटू ए भी लिख सकता है, ऐसा होता है, या दिस इज द रूल। अब यहाँ पे देख भाई, कोई पूछा डेट ऑफ एडजॉइंट ए क्या होगा, ये रूल बहुत इंपॉर्टेंट है, n-1 थियरी बहुत टाइम ले रहा है यार इसका। एडजॉइंट ऑफ एडजॉइंट ए, इसको क्या लिखेगा भाई, डेट ए टू द पावर ऑफ n-2 इंटू ए, यू आर गोइंग टू राइट डेट ए ना डेट ए, राइट। इसका वीडियो आएगा तो मैं सब सीधा कर देने दूंगा यार इसको। adjoint of adjoint A, suppose if I write indeterminate, then it has to be written as det A to the power of n-1 whole square. Suppose here adjoint 3 times are there, adjoint 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 A, so you are supposed to write what Nana, you are supposed to write det A to the power of n-1 whole cube Nana, ऐसा लिखना है, right। and you see here adjoint A transpose है, okay, adjoint A transpose है, तो तू क्या लिख सकता है भाई, एडजॉइंट ए ट्रांसपोज भी लिख सकता, राइट। एंड हियर एडजॉइंट ए भी है, तो क्या लिख सकता है भाई, एडजॉइंट ए इंटू एडजॉइंट, नहीं सॉरी, एडजॉइंट बी इंटू एडजॉइंट ए लिख सकता, राइट। अगर से कोई बोला तेरे को एडजॉइंट के ए, ये प्रॉपर्टी सबको सीधा सीखना है भाई, के टू द पावर ऑफ n-1 एडजॉइंट ए आता, राइट, ऐसा आएगा। अब देख भाई, इसमें जितने बार एडजॉइंट रहेगा उतने बार यह पावर बदलेगा बोल के पता चल गया तेरे, दैट आई डोंट वांट टू राइट दिस वन। सो नाउ द लास्ट पॉइंट इज देयर इन थर्ड वन, व्हाट इज दैट, इनवर्स, इनवर्स ऑफ ए मैट्रिक्स, ये एक ही बचा हुआ है, इनवर्स ऑफ ए मैट्रिक्स, व्हाट इज दैट इनवर्स, इफ ए इज अ नॉन सिंगुलर मैट्रिक्स, सिंगुलर नॉन सिंगुलर बोलना है, देख यार ये स्क्वायर मैट्रिक ले ले यार, ये क्या है, स्क्वायर मैट्रिक है। अगर से देख भाई डेट ए इज इक्वल टू 0 हो गया, उसको बोलते हैं अपन सिंगुलर, सिंगुलर बोलते। अगर से डेट ए नॉट इक्वल टू 0 हो गया, उसको बोलते हैं अपन, देखिए यार डेट ए अगर से 0 हो गया उसको सिंगुलर बोलते, डेट ए नॉट इक्वल नॉन सिंगुलर बोलते, राइट। ऐसा लेना, पहले क्या बोलना, ए भी है नॉन सिंगुलर मैट्रिक, ए लेना है अपने को, इस तरह का ये नहीं लेना है, शुड नॉट टेक, वी शुड टेक दिस, ओके, डेट ए शुड नॉट बी 0, वो लेना है। इफ एनी मैट्रिक इज सेटिस्फाइंग, एनी सच मैट्रिक इज सेटिस्फाइंग दिस रूल, ए बी इज इक्वल टू बी ए इज इक्वल टू आई एन बन रहा, तो अपन बोल सकते, राइट। ये बोलने का मतलब क्या है, B is denoted by inverse of A. And how we are going to write A inverse as our limit. Now, what are the properties of this means A inverse whole inverse is equal to A हो जाएगा भाई. A transpose whole inverse is equal to A inverse transpose हो जाएगा. So यार AB whole transpose whole inverse. So B inverse A inverse हो जाएगा. Right. अब कोई पूछा तेरे को adjoint of A inverse क्या होगा, तो लिख ले भाई, adjoint A लिख, उसका inverse लिख ले, वो भी करेक्ट हो जाएगा. अब देख A इज अ डायगोनल एलिमेंट है, डायगोनल मैट्रिक्स है, A1 A2 सो ऑन AN है. तो A इनवर्स क्या होगा? A इनवर्स कुछ भी नहीं, सिंपल है. ये भी डायगोनल ही रहेगा, लेकिन यहाँ पे 1/A हो जाएगा, 1/A2 हो जाएगा, से 1/AN हो जाएगा, ऐसा. सो इसलिए क्या लिखते हैं यार, A इनवर्स डेट ऑफ A इनवर्स इज इक्वल टू 1/det लिख सकते, यानी तो det इनवर्स भी लिख सकते अपन. ये है बातें इनके बारे में, इनवर्स के बारे में ऐसा आएगा. Anybody have any doubt in second part?
No, sir.
Right. लास्ट पार्ट इसमें क्या बचा हुआ है भाई? अब बचा हुआ है तो सिर्फ एक ही है, लीनियर इक्वेशंस. लीनियर इक्वेशन टोटल थियरी का है ये वीडियो, हो गया. तो इसमें सब प्रॉब्लम करते चले जाएंगे. लीनियर इक्वेशंस आर टू टाइप्स. वन इज होमोजेनियस इक्वेशन, अनदर वन इज नॉन होमोजेनियस इक्वेशन. ओके, इक्वेशन नॉन होमोजेनियस इक्वेशन. होमोजेनियस इक्वेशन क्या है भाई? a1x प्लस b1y प्लस c1z इज इक्वल टू 0. देखो यार, a2x b2y c2z इक्वल टू 0. यहाँ पे a3x b3y c3z इज इक्वल टू 0. इसको बोलते हैं होमोजेनियस. दैट मीन्स कांस्टेंट इज ऑलवेज 0. इसको नॉन होमोजेनियस, a1x प्लस b1y प्लस c1z इज इक्वल टू d1, a2x प्लस b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. ए वीडियो के लास्ट में सेकंड पार्ट ऑफ लास्ट आई वुड लाइक टू एक्सप्लेन रैंक. अभी एक्स रैंक बीच में नहीं लगा रहा हूँ, छोड़ दिया इसको. रैंक आपको थर्ड सेकंड वीडियो के लास्ट में बता देता हूँ अलग से. राइट, यहाँ पे बीच में नहीं गुजार हो यार, ओ एचेलॉन फॉर्म भी बता देता हूँ. राइट, यहाँ पे देखो लीनियर इक्वेशन ऐसा लिखे. If you write like this, Nana, A1, A2, A3, B1, B2, B3, C1, C2, C3. If you write like this, and here X, Y, Z in this way, and now you see this 0, 0, 0. Right, this is what A, and this is X variable matrix, and this is constant matrix. This is coefficient matrix, variable matrix, constant matrix. यहाँ पे क्या होगा भाई? A1, B1, C1, A2, B2, C2, A3, B3, C3, same as it is, but here X, Y, Z as it is, but here D1, D2, D3 आएगा. ये constant matrix है, इसको B बोलते हैं अपन, X है, ये है, same as it is. This is linear equations, homogeneous. This is linear equation, non-homogeneous. यार यहाँ पे फंडा क्या है, इसको सॉल्व कैसे करते हैं? ओके, होमोजेनियस इक्वेशन. ओके, होमोजेनियस इक्वेशन कैसे सॉल्व करेंगे? करने का तरीका कोई नहीं, सिंपल सी बात है भाई. डेट ए, अगर से डेट ए इज इक्वल टू 0 हो गया, दो ही केसेस है इसमें. अगर से डेट ए इज इक्वल टू 0 हो गया, नॉट इक्वल टू 0 हो गया, डेट ए नॉट इक्वल टू 0 हुआ, तो समझ लेना यार उसका रिजल्ट एक्स भी 0, वाई भी 0, जेड भी 0. इसको क्या बोलते हैं अपन? ट्रिवियल सॉल्यूशन बोलते हैं. ट्रिवियल सॉल्यूशन मतलब एक्स वाई जेड पूरे के पूरे 0, पूरे के पूरे 0 है. अगर से डेट 0 नहीं हुआ तो ट्रिवियल सॉल्यूशन. यू कैन कॉल इट एज यूनिक सॉल्यूशन भी बोल सकते हैं, यूनिक सॉल्यूशन, दोनों में से कोई एक बोल सकता है. राइट, जब सॉल्यूशन है तो उसको बोलते हैं कंसिस्टेंट. व्हाट इज द मीनिंग ऑफ कंसिस्टेंट? मीन इट हैज अ सॉल्यूशन. राइट, दैट्स व्हाई. सेकंड वन देख भाई, अगर से डेट ए इक्वल टू 0 हो गया, समझ पाए, इसको क्या बोलते हैं? नॉन ट्रिवियल सॉल्यूशन. नॉन ट्रिवियल सॉल्यूशन, पूरा थ्योरी बता दिया. नॉन ट्रिवियल सॉल्यूशन में क्या होगा? क्या होगा मतलब एक्स वाई जेड एनीथिंग, एनीथिंग मे बी, ऑल रियल नंबर्स आ जाते. इसका इन्फिनिटली मेनी सॉल्यूशंस रहते, मेनी सॉल्यूशंस रहते. कभी एग्जांपल लेके बता देता हूँ. देखो इसको क्या होगा? नॉन ट्रिवियल सॉल्यूशन मींस हियर नॉन ट्रिवियल पे तो 0, 0 नहीं, 0, 0 के अलावा दूसरा, मतलब एवरीथिंग इज देयर, इन्फिनिटली मेनी सॉल्यूशंस आते. AIB में करते हैं, इस बार देख लेना, right? Non-trivial solution it is. Infinitely many solution you can say. Now come to the next one. इसमें तो क्या है? That's why we can say that homogeneous equations are always consistent. Homogeneous equations are always consistent. यार अभी नॉन होमोजेनियस इक्वेशन के बारे में आऊंगा. नॉन होमोजेनियस इक्वेशन के बारे में जब आओगे, इसमें मेथड 1 के बारे में देखो. वो क्या करेंगे यहाँ देखो यार. फॉर एग्जाम्पल मेथड 1 में देखो यार, डेटे ले लो. दो केसेस आएंगे आपको. डेटे इज नॉट इक्वल टू जीरो एंड डेटे इज इक्वल टू जीरो हो जाएगा. डेटे इज नॉट इक्वल टू जीरो जब आ गया तो यू कैन से दैट यूनिक सॉल्यूशन. बात ही खत्म. कुछ बोलने की जरूरत ही नहीं है. आपको आंसर आ जाएगा. एक्स एंड वाई की वैल्यू आ जाएगी. एक्स वाई जेड వాల్యూస్ వచ్చేస్తాయిరా. అందుకని మనం ఏం చెప్పాల్సిన అవసరం లేదు నాన్న. बट डेट ए इज इक्वल टू जीरो है, तब क्या होगा? दो तीन केसेस आएंगे. इसको डेट ए को मैं क्या बोल रहा हूँ यार? डेल्टा बोलूंगा. समझ लो आप. अब देखो यार, डेल्टा वन होगा. डेल्टा वन अगर से जीरो हो गया, देखो डेल्टा वन, डेल्टा टू, डेल्टा थ्री, तीन भी जीरो, तीन भी इक्वल हो गए, तो इन्फिनिटली मेनी सॉल्यूशन होगा. और एनी वन ऑफ डेल्टा वन, डेल्टा टू, डेल्टा थ्री नॉट इक्वल टू जीरो, नॉट इक्वल टू जीरो, नो सॉल्यूशन. अब ये यार डेल्टा वन क्या है? डेल्टा वन ये है यार, इफ यू रिप्लेस C1 by B elements, D1, D2, D3 ऐसा. Okay, B1, B2, B3, right? C1, C2, C3. This is delta. Delta 2 is nothing but like this. Okay, A1, A2, A3, D1, D2, D3, C1, C2, C3. एक मेथड हो गया. अरे यार डेल्टा 3 भी ऐसे आएगा. A1, A2, A3, ओके, B1, B2, B3, C1, C2, C3 ऐसा आएगा. ये भी है पूरा. इसको बोलते हैं यार. एक मेथड हो गया. और एक मेथड क्या है यार इसमें? M2 देखो यार. M2 में क्या है? डेटे ले रहे हैं आप. दो केसेस बनते हैं यार. डेटे नॉट इक्वल टू जीरो, डेटे इक्वल टू जीरो हो रहा. इसमें क्या करेंगे? इनवर्स से जाएंगे अपन. देखो यार, ए इनवर्स मतलब क्या होगा अपने को? एडजॉइंट ए बाय डेटे होगा. तो वो यूज कर रहे हैं अपन. क्या है यहाँ पे? एडजॉइंट ए इंटू बी इज इक्वल टू जीरो. और एडजॉइंट ए इंटू बी कभी थियरी में पूछ लिया तो बोलना नॉट इक्वल टू जीरो. इन्फिनिटली मेनी सॉल्यूशंस को, नो सॉल्यूशंस को, यहाँ यूनिक सॉल्यूशंस. एक रूल हो गया. M3 भी है भाई. क्या लिखना बोल एक यार, इसको बोलते हैं एचेलॉन फॉर्म. ए बी दिखता कैसा भाई? देख ले. A1, B1, C1, D1, A2, B2, C2, D2 एंड A3, B3, C3, D3 ऐसा लिख दिया भाई. लिख के क्या करा? बाय रो ऑपरेशन, ओनली बाय रो ऑपरेशन. इफ यू चेंज लाइक दिस, सपोज इफ यू चेंज इन दिस वन, P1, P2, P3, P4, right? And 0, P5, P6, P7, 0, 0, P8, P9 ऐसा है. तो यहाँ पे तीन केसेस आते हैं. केस वन देख भाई, P8, P9 दो भी जीरो हो गए. समझ, दो भी जीरो है मतलब यार ऐसा आ रहा. P1, P2, P3, P4, 0, P5, P6, P7 बाय अप्लाइंग रो ऑपरेशंस. ऐसा है. इन्फिनिटली मेनी सॉल्यूशन होते. केस टू, अगर से देख भाई, P8 इज नॉट इक्वल टू जीरो है. मतलब ऐसा P1, P2, P3, P4 आएगा 0, P5, P6, P7, 0, 0, 0, ये P8 आएगा. अब P9 कुछ भी रहने दे भाई, वो जीरो होने दे, कुछ भी रहने दे, वैल्यू आ जाएगा. यूनिक सॉल्यूशन. अब सोच यार, तो केस 3 है. व्हाट इज दैट? P8 इज जीरो एंड P9 इज नॉट इक्वल टू जीरो. तो उसका शेप ऐसा आएगा ना. P1, P2, P3, P4, 0, P5, P6, ओके, P7 एंड यहाँ पे 0, 0, 0 या P9 रहेगा ऐसा. सो दैट्स व्हाई इट इज हैविंग व्हाट? नो सॉल्यूशन. सिंपली यहाँ पे क्या बोलना? नो सॉल्यूशन, यूनिक सॉल्यूशन, इन्फिनिटली मेनी सॉल्यूशंस. ठीक है, ये पूरा थियरी खत्म हो गया. Yeah, last method is this one, है ना? Yes, what you are supposed to do is here equation 1, equation 2 you select and try to avoid this C1, C2 term while multiplying C2 here, C1 over here, and simply subtract. We'll get like this. Assume that it is happening like this, some D1. Okay, and now while taking the first two, now you take down second and third one, and in the same way you multiply C3 here and multiply C2 to this equation and simplify. You may get, let us assume that it is, you got it as D2. Suppose these two equations are satisfying this rule, then you can say that infinitely many solutions. If these equations are satisfying this rule, you can say that no solution. And you got it as a point of intersection, you can say that unique solution. Okay, unique solution. Okay, like this. This is what, with this, the theory part is totally completed. Oh, once again, you please checked out what we did right from the beginning. Just, I'll repeat, just check it out here. Yeah, you just check it out, Nana. Here, we started. See, we started matrices like this. This is the part one. Whatever I said it here, a rectangular arrangement of numbers in rows and columns. Matrix, order of a matrix I defined in this way. And a column of a matrix, then afterwards we discuss. Only here, one example I have given here, 2 by 1 and 3 by 1. And row matrix, here definition, I wrote whatever I said, I wrote the definition. A matrix is said to be what? Row matrix if it contain any only one row and any number of columns. Yeah, I have given two examples. Singleton matrix means it should have what? Only one element. You can write 1, 2, whatever it may be. The order is 1 by 1, never going to be changed. And null matrix, yeah, we are going to indicate with O. Right, Nana? We are going to with O. Either it may be what? 2 by 2 or 3 by 2, whatever it may be, the order. But the condition is here, all elements are what? 0, I said. Rectangular matrix, we define in this way. Okay. Now come to the next one. So, yeah, square matrix. Then afterward, principal diagonal I defined here. Diagonal matrix we discuss. Scalar and trace of the matrix. Upper triangular matrix here. Everything I wrote the definition clearly. See this one, Anna. It will be like this. One example I have given here. And lower triangular matrix, you know very well. This is a condition. It has to happen, and you got it in this way. Submatrix means after deleting the number of rows and columns, whatever is left okay, then it is called submatrix. We have got various kind of submatrix. I said, yeah, here it is there. Equal matrix means their order should be equal and the corresponding elements are equal. Then you can say that equal matrix. Here, addition of matrix is possible only if the order of the two matrices are what? Same. I have taken here 3 examples, right? And then afterwards here I shown to you that how to add, and whereas here addition is not possible, the reason you know very well, right? We discuss and properties of addition of matrix, commutative law, associative law, addition of additive identity. Okay, and it is inverse. Right, inverse. Additive inverse is what? Minus A, and cancellation law also we discuss. Scalar multiplication of matrices. And these are the rules, 2 rules here we discuss. Right? And 2 rules we discuss here, Nana. And subtraction of matrix. Yeah, order is same. You can subtract here. If order is not, subtraction is not possible. Product of a matrix means I have given you one example here. I have taken 1 by 2 order. This is what? 2 by 1 order. So these two are same. Therefore 1 by 2, 1 by 1 we got it. So this is what? 1 by 1. 11 is the answer. When you multiply here 1 by 2 matrix, we got it. This is the answer. Okay. Now move on to the next one. The rules I wrote here clearly. Right? Trace of the matrix. I said it to you that here I is equal to j. I substituted here. Both are what? I. Right. Here I is equal to j I have taken. And properties of trace of matrix. Idempotent matrix condition I said it to you that a square is equal to a fine. And periodic matrix, this is the condition you remember, and whatever the definition I said, here it is there. Nilpotent matrix, yes, it is a square matrix and it has to satisfy this condition, a to the power of k equal to 0. Yeah, we did it here. One example I gave it to you. And here involutory matrix, same as it is. A inverse is a square equal to I. Transpose of a matrix also I discussed here. And here properties of symmetric matrix, skew symmetric matrix, and why this one is symmetric, why this one is skew symmetric, I discuss here clearly, right? And afterwards some properties, some important point related to symmetric matrix also we discuss, and skew symmetric matrix also. Orthogonal matrix means like this, Nana. Determinant of a matrix clearly I discuss here. This is the first point, and this is second point, right? This is second point, and this is the what? First point. After that, here I explain here minor and cofactor. Okay, minor and cofactor. Okay, minor and cofactor. Clearly I discuss. And you see this one, Anna. Here I discuss the properties of determinant here. 1, this is 2, this is 3, this is 4, right? And afterwards I have taken here another example. One row contains 0, one column contains 0. Yes, these two are the example. Two rows are equal, two columns are equal. And here one row is proportional to other, one column is proportional to other. Yeah, here if you subtract any two columns, nothing will happen, same as it is. And something column related operation also you do, the determinant is not going to be affected as discussed. Here also I discussed this one, R1, R2, row wise also I shown to you. Later onwards I discuss adjoint. Clearly I explain this all things now. You just go through this, all things you will come to know. Yeah, we can express one determinant as sum of the two determinants here, and afterwards adjoint clearly explain why, etc. See these brackets, all these brackets I explain as what? A1, A2, A3, B1, B2, B3. Transpose means it is going to be happen like this, and this is nothing but the adjoint of a matrix, right? And afterwards the properties of adjoint also I wrote clearly. You need to check it out. Inverse of a matrix is there, and here all the properties I discuss here. And afterwards, linear equations. This is homogeneous, and linear equations are two types. I said one is homogeneous equation, another one is non-homogeneous equation. And here we discuss homogeneous equation two cases, and two cases are what? One is unique trivial solution, another one is infinitely many non-trivial solutions. A non-homogeneous equation I discuss four cases. One case is the previous one, the second case is this one, and the third case echelon form. In this one also I discuss here when, why it is. And the last one is a general one, a plane like maybe if you treat these are what planes, just avoid C Z here by taking these two equations, and here also like this. So I discussed thoroughly in this one all theory points. Now we'll move on to the next questioning. Nana. Questions we have to do 30 and one. Okay, one question, 30 questions and one question paper is there. Let us discuss in the next video. Bye.